A blended wing body is a fixed-wing aircraft having no clear dividing line between the wings and the main body of the craft. The form is composed of distinct wing and body structures, though the wings are smoothly blended into the body, unlike a flying wing which has no distinct fuselage. A BWB design may or may not be tailless. The potential advantages of the BWB approach are efficient high-lift wings and a wide airfoil-shaped body. This enables the entire craft to generate lift, potentially reducing the size and drag of the wings. A blended wing body can have a lift-to-drag ratio significantly greater than a conventional craft, offering improved fuel economy. The BWB configuration is used for both aircraft and underwater gliders. History: the 1924 Westland Dreadnought was built on the basis of the theories of M. Voevodsky after wind tunnel tests. It stalled on its first flight, severely injuring the pilot, and the project was shelved by the British Air Ministry. The Miles M30X Minor of the early 1940s was an experimental aircraft to test the blended wing fuselage design for a proposed large airliner. The McDonnell XP-67 prototype interceptor also flew in 1944 but did not come up to expectations. NASA studied the concept more recently with a computer-stabilized 17-foot model called BWB-17, built by Stanford University, which was flown in 1997 and showed good handling qualities. From 2000 NASA went on to develop a remotely controlled model with a 21 feet wingspan. This research is focused on establishing the base data concerning the lift, stall and spin characteristics inherent in a blended wing body design. NASA has also jointly explored BWB designs with the X-48 unmanned aerial vehicle. Studies suggest that BWB aircraft, configured for passenger flight, could carry from 450 to 800 passengers and achieve fuel savings of over 20%. Other suggestions are better access to emergency exits. Unfortunately, potential passengers disliked the internal seating arrangements and the program changed its focus toward cargo aircraft. Characteristics: the BWB form minimizes the total wetted area, the surface area of the aircraft skin, thus reducing skin drag to a minimum. It also creates a thickening of the wing root area, allowing a more efficient structure and reduced weight compared to a conventional craft. NASA also plans to integrate ultra-high bypass ratio jet engines with a hybrid wing body. The wide interior spaces created by the blending pose novel structural challenges. NASA has been studying foam-clad stitched fabric carbon fiber composite skinning to create uninterrupted cabin space. Potential advantages significant payload advantages in strategic airlift, air freight and aerial refueling roles, increased fuel efficiency, lower noise. NASA audio simulations show a 15 dB reduction of Boeing 777 class aircraft, while other studies show 42 dB reduction below stage 4 level depending on configuration. Potential passenger safety problems. Evacuating a BWB in an emergency could be a challenge. Because of the aircraft's shape, the seating layout would be theater-style instead of tubular. This imposes inherent limits on the number of exit doors. In order to fully realize the potential advantages of the BWB design in a large aircraft, the engines are typically placed above the rear fuselage. Air safety authorities have expressed a concern that in an accident they could become detached and their momentum carry them forward so that they fall onto the passenger cabin. Marine applications. The BWB concept is also being used in underwater gliders. The U.S. Navy Office of Naval Research is testing an autonomous glider called the Liberdade class. In popular culture. Popular science concept. A concept photo of a blended wing body commercial aircraft appeared in the October 2003 issue of Popular Science magazine. Artists Neil Blomkamp and Simon van der Legemout from the Embassy Visual Effects created the photo for the magazine using computer graphics software to depict the future of aviation and air travel. It is likely the photo was inspired by models of BWB 450, a pre-X-48 concept designed in the late 1990s, or the X-48A concept designed around 2001. The image was subsequently used in emails since 2006 claiming that Boeing has developed a 1,000-passenger jetliner with a radical blended wing design in direct competition to the Airbus A380. Boeing denied the claim at the time. List of blended wing body aircraft. See also, List of flying wings, lifting body. References. Notes Bibliography External links. NASA's X-48B blended wing body page, a Euro blended wing Euro unregistered trademark craft passes wind tunnel tests, newscientist.com News Service, November 14, 2005, How Design of SAX-40 Aircraft Reduces Noise and Improve Efficiency, Progress on the Winco Atlantica Small BWB Plane, Airliners.net Photo of the Atlantica prototype aircraft, July 2004, Truth or Fiction on the rumor of the Boeing 797 blended wing passenger liner, blended wing body, HAW Hamburg, photorealistic image of blended wing airliner taxiing at airport, a blended wing body concept by Cranfield University, NASA Facts, the blended wing body, design challenges for the 21st century.